A 15 microcoulomb charge is placed at the origin. A second negative 10 microcoulomb charge is placed 1 meter to the right of the first one. What is the electric field at x equals to 3? So this is the first one, which is positive 15 microcoulomb. And here we have negative 1, 10 microcoulomb. And we need to find out the magnitude and direction of the field at this point. So if I call this one Q1 and Q2, field due to the presence of Q1 is gonna go this way. I'm gonna call it E1, and due to the negative 1 is gonna go this way, E2. We need to find out the magnitude of E1 and E2. E1 will be, and by the way, the distance here is 1 meter and here is 2 meters. So it's K Q1 divided by R squared. K is Coulomb constant, 8.99 times 10 to the power of 9. Q1 is 15 times 10 to the power of negative 6 divided by R squared, which is 3 squared. That will be 8.99 times 10 to the power of 9 times 15 times 10 to the power of negative 6 divided by 9. That will be 1.49 times 10 to the power of 5 Newton per Coulomb. E2 is K Q2 divided by R prime squared, which is going to be 8.99 times 10 to the power of 9. Q2 is 10 times 10 to the power of negative 6 divided by 2 meters. That's going to be 8.99 times 10 to the power of 9 times 10 times 10 to the power of negative 6 divided by 4. That will be 2.25 times 10 to the power of 4 Newton per Coulomb. This one is 4 as well. So as you see here, E2 is greater than E1. So E net will be E2 minus E1. And that's going to be 2.25 minus 1.49 times 10 to the power of 4. That's going to be 7.6 times 10 to the power of 3 Newton per Coulomb. And it's going to go toward left because E2 is greater than E1.